Hi guys, thank you so much for joining us today for the live stream for mock AMC 10 mock exam number 2. This is the Pure Genius team right here, and we just wanted to, before we start, a couple of things. First, we want to apologize for the technical difficulties that we've been having today, and that the live stream is actually going to be occurring on YouTube as opposed to Pure Genius. As a result of that, there will be no one-on-one channel that you can switch off onto like you did in Pure Genius. But there is a chat box in the YouTube live stream, which you can type any questions that you have in there, and we will definitely help you via the YouTube chat box. Another thing is that we'll be taking a 5-minute intermission after question 15. And so without further ado, we're just going to start off on question number 1 and work our way up to the end of the exam. Thank you.
Hi, I'm Soham. So I'm going to start off with doing number 1, and also just know that we're going to still have our gurus on the YouTube live chat ready to answer your questions. So don't be afraid to ask if you have any, and yeah, just make sure to ask. So number 1, if Bob is in the exact middle of a line, there's an equal number of people in front of him and behind him, which could be a possible number of people in the line. Okay, so this question is pretty much, it's just asking to find the median of like a data set. So there's just like X number of people here, someone here, and then X number of people, which means there's 2X plus 1 number of people, which means it's an odd number of people. And the only odd answer choice is C, which is 15. So we're gonna go on now to manage.
Marker. Okay, so I'll erase this quickly. Number 2 was a pretty straightforward question. So there are 6 pairs of socks, and we have, and then we're trying. So there are 6 pairs of socks, meaning there are entirely 12 socks. So A, B, B, C, C, D, D, E, E, F, F. And it says, how many socks should I grab to guarantee I have a pair? So the worst case we can have, for the first 6 grabbing of socks, we can have all different socks. That's the worst case it can happen. But after the 7th one, it is guaranteed that the next one is going to be, next socks we're going to pick is going to be one of these 6. So at the 7th turn, we're going to be able to get a pair of socks. So the answer is 7, which is E. And number 3, we have Ian. Explain.
Awesome. So just so you guys know, this last problem was a problem about the pigeonhole principle. Now for number 3. So number 3 is saying you've got numbers A, B, and C, which are in a geometric sequence, meaning A times a constant equals B, B times a constant equals C, and so on. And you know that A is equal to 2/3 B. And C is equal to 27. So now, because you know they're a geometric sequence, you don't know the precise order, but you can take a guess and say that your multiplier is 3/2, so 3/2 A equals B, and 3/2 B equals C, and you know C is 27, so if you work backward, you can say that A is equal to 12. This is one of the answer choices you can find, so you can say, okay, A equals 12 is your answer. Alright, now we're going to have Sushant do problem number 4.
Okay, so I'm gonna do number 4. It asks you the number of multiples from 1 to 1,000 that are multiples of at least 1 of 2, 3, or 5. So there are 10,000 divided by 2 multiples of 2 from 1 to 1,000, and there are 1,000 divided by 3, the floor of this, multiples of 3 from 1 to 1,000, and the same goes for 5. Now we need to subtract the multiples of 6, 15, and 10 because we're overcounting them in each of these cases. So we have to subtract 1,000 over 6, subtract 1,000 over 15, and subtract 1,000 over 10. And finally, we have to add back 1,000 over the LCM of all 3 of these numbers, which is 30, because of principle of inclusion and exclusion. Yes, sorry, 10,000. Okay, so all of these 1,000s are actually 10,000s. And if you expand all of this out and you do the divisions, you're gonna get 7, 3, 3, 4, which is D. And yeah, that's it.
So yeah, if anyone has any questions, make sure to ask in the YouTube live chat. We have our gurus on standby, ready to help. Okay, so we're gonna move on to number 5 now. So. Okay, so number 5. Can I see your laptop? Do you have it open? Okay. Number 5. In a room, 2/5 of the people are wearing gloves and 3/4 of the people are wearing hats. What is the minimum number of people in the room wearing both a hat and a glove? Okay. So 2/5 for gloves and 3/4 for hats. So just making this a common denominator, that means there's 8 over 20 wearing gloves and 15 over 20 people wearing hats. So that means the number of people in the room has to be 20, and given that the number of people are 20, that means, and 8 people are wearing gloves and 15 are wearing hats, that means 8 plus 15 people equals 23 are wearing some article of clothing, which means 3 people overlap, and 3, that means have to be wearing hats and gloves, which means your answer should be A. So also, yeah, just make sure to ask any questions you have with anything that you see. Yeah, we have our gurus on standby, so yeah. Yeah.
Wait, it's off right now, right?
Number 6 was a system of equations, and actually there was a typo on the test because none of the answer choices matched the answer you got at the end. And where's the black marker? Okay, so the first thing you can do is multiply all these equations and clear the denominators. So when you do that, you're gonna get 6a minus 9b plus 3c equals 10, 17b plus d equals 0, and 25a minus 3b minus c minus d equals negative 11, 13a plus 6b minus 4c plus 2b equals 81. Okay, so the first thing is we can use this equation to eliminate d, because this implies that d equals negative 17b. And when you do that, you're going to get a 3-variable system of equations, and that 3-variable system is going to be 13a minus 28b minus 4c equals 81, 25a plus 14b minus c equals negative 11, 6a minus 9b plus 3c equals 10. Okay, and I'm going to erase this. And so the problem amounts to just solving that system. And so the first thing you notice is that this c, its coefficient is negative 1. So we can use it to eliminate all the other c's in this equation. And so we can add 3 times this equation to eliminate the c. And when we do that, we're going to get 81a plus 33b equals negative 23. And for this equation, we can multiply it by negative 4 and subtract it from that equation. And when we do that, we're going to get negative 87a minus 84b equals 125. And now you can solve this like any 2-variable system, and you're going to get that b equals 2708 over negative 1311. And this is actually really close to negative 2, but because it's not negative 2, we still get free points to everyone that answered it.
All right, so question number 7, it's saying you have the number 101 to the 99th power, and you're trying to figure out what the 3-digit remainder of this answer is. You know that the 1-digit remainder of the answer is going to be 1, because 1 times 1 is always 1 up to infinity. Now what you have to figure out is whatever this number is going to be, and this is a bit more complicated. But the way you do it is essentially you do 101 times 101, and you can actually so 101 times 101, and you get 10201. You multiply 101 times that, you get 1030301, and you can find a Pascal's triangle in this pattern, where you have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. And if you keep going on to infinity, your this digit is always going to be this digit in Pascal's triangle. So if you keep going down, this digit for 99 in Pascal's triangle is going to be 99. So you know that your answer is going to be 9901 for the last digit, or 901 because it's only 3 digits. So your answer choice is E. All right, now we're going to have Sushant do number 8.
Also, just an easier solution to that, like something else that you can think of is like 101 times 101 is equal to 101 times 100 plus 101. So it's like you're going to add 2 zeros and add a 101. And then, so you get 12201, and then after you multiply by 100, and then add another 101. So, wait. Okay. Okay, so, oh, okay, sorry. So you add this, and then you add another 10201. So then you can goes to 301, and then 2 zeros. Okay. So you can see the pattern again, just showing up as 201, 101, 301, 401. So that's just another way to think of it. Yeah. So now we're gonna have Sushant come up, and then yeah, I'll just leave this up for a little bit, and then yeah, make sure to ask questions.
Quadratic x squared minus 33x plus a. And we're given that its roots are both prime numbers. So let's just say that this is equal to x minus p into x minus q for prime p and q. So when we expand this, we're going to get x squared minus p plus q x plus pq. So if we equate coefficients, we get that p plus q equals 33, and that a equals pq. And so basically this amounts to trying to find two prime numbers that sum to 33. And you can guess the solution to be 2, 29. And once you do that, you can calculate a to be a equals 2 times 20, this should be 31. And a is 2 times 31, which is 62.
What letter, what number is that? Or what?
8.
Oh, as in, is it?
It's C.
C.
C. So the answer is C.
Okay. Yeah. So let's move on to number 9 now. Number 9, the sum of the lengths of the diagonals of a quadrilateral is 8. What is the maximum possible area of that quadrilateral? Okay. So, I just draw like two diagonals like that. So the area of a quadrilateral with two perpendicular diagonals is just the two diagonals multiplied divided by 2. So the intuition behind making the diagonals perpendicular is like basically that when you find like the area of this triangle, you can find it by 1/2 AB sine C, and then so let's say like that's A, that's B, so like 1/2, and then that's angle C. So yeah, 1/2 AB sine C would be the area of that, and sine C is going to be maximized when C equals 90 degrees. So that means that's why that should be the right angle. After that, it says the sum of the lengths of the diagonals of a quadrilateral is 8. So let's say just the two lengths are like m and n. That means m plus n equals 8. Also, so since they're perpendicular, that means the area of the quadrilateral is mn over 2. So just going back to AMGM inequality, you just get, so m plus n over 2 is greater than or equal to the square root of m. So, yeah, so just 4 is greater than or equal to square root of mn. 16 is greater than or equal to mn, which means 8 is greater than or equal to mn over 2. It also says maximum possible area of that quadrilateral. So it's maximized when mn over 2 equals 8. And yeah, so that is the answer choice C. Yeah. And then just for the condition for AMGM being equal is that m and n must be equal. So like the vector that you have, if you have like a vector a1, a2, just like that, and they're all equal to each other, that's when this inequality is equal. So that's the equality condition. So for all of the inequalities that you're going to use on the AMC, just know the equality case as well, because that's really important to know. Okay, so I'll leave this up here for a little bit and make sure to ask questions if you have any.
So in problem 10, so there were a set of non-negative integers and their average was 20. So let's say there were x amount of integers and the sum was 20. So we find the average by finding the sum of all 20 all the numbers and dividing it by the amount of numbers. That means if this is the average and this is the amount of numbers, so this is going to be the sum of all the numbers, and you added 120 to the set. So if you add 120 to the set, and that means since there were originally x amount of numbers, but you added one more number, so it's total of x plus 1. So this is the new average, which in the problem it says it's 40. So now you can just solve this equation. 20x plus 120 equals 40 times x plus 1 by multiplying x plus 1 on both sides. So it's 20x plus 120 equals 40x plus 40. And now you can just solve the equation and you get x equals 4. So the answer should be B.
All right, awesome. So I'm going to leave this up here for one more moment. And let's get on to problem 11. All right. Triangle ABC with its right angle on angle A, and your altitude AD, with AB is equal to 11 and AC is equal to 22. And you're asked to solve for the ratio of BD to CD, and so the way you solve this is you know that 11 squared plus 11 squared is equal to BD squared plus AB squared, and you know that 22 squared is equal to BD squared plus CD squared plus AD. CD squared plus AC squared. CD squared plus AD squared. Yes. Okay. All right. I think I got it right. What you're doing is you're solving for this right triangle. You're saying that 11 squared is equal to AD squared plus BD squared, and you're solving for this right triangle. 22 squared is equal to AB squared times BC squared, and so what you do is you have to solve out the systems of equations, and you can say that BD squared is equal to 11 squared minus plus AD squared, and CD squared is equal to 22 squared plus AD squared. You divide both of these and you take the square root of it. So we get BD over CD is equal to 11 squared plus AD squared over 22 squared plus AD squared, the square root of all of this, and then I'm not. Wait, no, it's minus. Okay, it's minus. Wait, oh, wait, no, it's minus. Oops.
You can also do it this way, but you can actually solve it without without squaring the sides. So when you look at it, there are so many similar triangles you can find. The first one is triangle BD is similar to triangle BCA, and this is 1 to 2, meaning this is gonna be also 1 to 2. So if this side length is K, this side length is gonna be 2K. But when you look at it, triangle ADC is also similar to triangle BAC, ADC and BAC, and it's also 1 to 2, and this should be 1 to 2, so this is 4K, and we were trying to find BD to CD, so it should be 1 over 4. Is it 1 over 4?
Yeah.
And it should be letter E. And number 12.
So if you have any questions with any of this, please feel free to ask. Okay, so I'm going to erase this. Which intersects at a 30-degree angle. And you know that AB is 20, AC is 100. And you want to use B as the center of a circle so that it's tangent to AC. Alright. And your goal is to find the diameter of this circle. So the first thing you notice is that because this is a point of tangency, it forms a 90-degree angle. And because this is 30 degrees, that means this must be 60 degrees. And so instantly you get this 30, 60, 90 triangle. And because of the 30, 60, 90 triangle ratios, the radius of this circle must be 20 by 2, which is 10. And because diameter is twice the radius, the diameter must be 2 times 10, or 20, which I believe is letter C.
So I'll just leave this up for a little bit again. Let's go to number 13. Number 13. What is the quotient when the base 8 number 3322 is divided by the base 4 number 1201? Express your answer in base 4 format. So, okay. So pretty much, this is kind of like a bash problem. So, and 1201 base 4. So what I did is pretty much convert everything into base 10. So this is going to be 2 plus 16 plus 192 plus 1536. And this is going to be 1 plus 32 plus 64, which is 97. I'm just going to add this out. Okay, so yeah, you never want to make any mistakes, arithmetic mistakes. So yeah, just always make sure you're checking your work as you're going. So 1746 divided by 97. And that should be 7, 8, Okay, so I'm pretty sure that's perfect, right? 6, 5, 7, 7. So now you have 18 in base 10, and then you want to make that into base 4. So pretty much, right? Yeah. So yeah. So now base 4 just 1, 4, 16, just 1 over 2. So in base 4. So your answer should be A then. Okay, so yeah, make sure to ask any questions if you have them. We're going to be moving on to Min now for number 14.
Okay, so let me just erase this quickly. Number 14, it said A plus 1 over B is 2. B plus 1 over C is 3. And C plus 1 over D is 4.
It's C plus 1 over A.
C plus 1 A. And we're trying to find A, B, C plus, well, at first glance, it might, you might not be able to find how we can go from here to here. So you just need to play with it a little bit. And what I did, I tried multiplying all of these 3. So I multiplied this. Which is A, B plus A over C plus 1 plus 1 over BC, C plus 1 over A, B, C plus A plus C plus 1 over B plus B plus 1 over C and 1 over A and AB 1 over ABC. And you will notice that what we're trying to find, ABC plus 1 over ABC, is this and that, but we have extra A plus B plus C plus 1 over A, 1 over B, 1 over C. So we need to subtract this from here to get that. Oh, by the way, so this, since we multiplied these 3, it should be 2 times 3 times 4, which is 24. And this, the one we need to subtract from this, is basically the sum of these 3, because A plus B plus C plus 1 over A plus 1 over B plus 1 over C. So this is 2 plus 3 plus 4, which is 9. So if you subtract 24, 9, you get 15, and it's D. Okay.
Awesome. So problem 15 is asking when the real numbers in the set 1, 2, 4, x and 2x are arranged properly in a geometric sequence, what are the possible values of x? So we have 1, 2, 4, x and 2x in a geometric sequence. Now, there's 3 different places where the x and 2x go in sequence. One is at the end. Another is at the beginning. 1, 2, 4, because you know you're multiplying 2 by this each time. But a third place you can put them is 1x to 2x and 4, where you're multiplying by root 2 each time. For this case, there's only one possible value. X has to equal 8. Similarly, for this case, there's only one possible value. X has to equal 1/4. But for this case, there are two different values. X can equal the square root of 2, in which case the whole sequence is positive, or x can equal the negative square root of 2, in which case it's an alternating geometric sequence. So we have 4 possible values of x, so D is your answer. All right.
So now we're gonna have a 5-minute break. So yeah, just make sure to tune in after 5 minutes. We'll go straight into it with number 16 with Sushan. Okay, thank you.
And we're back with problem 16. So Mike randomly picks two distinct prime numbers less than 30. So let's just go ahead and list out all the prime. And that's 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. And we want the probability that the sum of the two numbers he picked is even. So to get an even sum, you either need both of your numbers to be odd or you need both of them to be even. But the even case is impossible since the only way for both of these numbers to be even is if it's 2 plus 2. But we're given that he picks distinct prime numbers. And so the total number of ways he could have picked two distinct prime numbers is 10 choose 2, which is 45. And the number of ways in which he could have picked two odd prime numbers is 9 choose 2, which is 36. So the desired probability is 36 over 45, or 4/5, which is E. And passing it on to Soham.
Okay, so I'll leave this up for like 5 more seconds, and yeah, make sure to ask any questions that you have. Yeah, our gurus are waiting. So. Triangle ABC is a right triangle with angle BCA as its right angle. BC equals 30, AC equals 40, and let D be a point randomly chosen on side AB. What is the probability that the area of CBD is larger than 200? Okay, so ABC is a right triangle, and it says the angle BCA is the right angle. So given that BCA is the right angle, BC equals 30 and AC equals 40. So this is very obvious that it's going to be a Pythagorean triple 3, 4, 5. So that should be 50. And it's asking for D on point side AB. So let's say just D is like right here or something. So this, they're asking for the area of triangle CBD to be larger than 200. So the area of CBD is equal to the area of ABC minus the area of ADC. So the area of ABC equals 30 times 40 over 2, which is 600, and now it wants the area of CBD to be larger than 200. So we want area of CBD, or actually, right here. So area of CBD to be greater than 200. So that means we want, get from this inequality, or I mean this equality statement, we want area of ADC to be less than 400. Yeah. So now the area of ADC is equal to CA times, let's drop this perpendicular and just call that point X times DX over 2. And then that means CA is 40, so DX has to be less than 20. So so let's say at the max it's 20, which means the boundary point is that it's 2/3, or 20 over 30, which is 2/3. So under this point, if you put D, like anywhere here, then the area of CBD will be greater than 20, or the area of CBD will be greater than 200, because this length dx will be getting smaller. So let's just like call that x. So that means your probability should be 2/3. that the area of CBD is greater than 200. And that is the answer choice for A. So A should be your answer then.
What you can also do is problem 17. Since we know the area of triangle ABC, and if we drop an altitude, that means since we can actually find the area of triangle using this times this divided by 2. We can also do BA times the altitude divided by 2. So we know that AB is 50. So if we say altitude is h, 50h divided by 2 must equal 600. So h is 50 over 1200, which is 5 over 120. And now that we know the altitude, we can say we can let this length be x, and then that means the area of CBD is gonna be 1/2 times x times the h, the altitude of the CD. So is 5 over 120, and we're saying that this should be greater than 200. So, and then we can just solve for x and move on to, and then we can find the probability from there. Now for problem 18. So a and b are positive integers with b less than 101. So a and b are positive integers with b less than 101. And we are given a condition 2ab is a squared plus b squared. We can actually move this 2ab to this side by subtracting 2ab on both sides. So it becomes a squared minus 2ab plus b squared. And this is just a minus b squared. But any number squared, we know that any number squared is always greater than or equal to 0. So it is impossible to go negative. So what we're solving is a minus b squared equals 0. And the question has worded it weirdly, but it says which satisfy 2ab is greater than or equal to a squared plus b squared for a specific b. So what they mean by specific b is that, so what this is saying is a should equals to b. So for any b, there's only one value of a that satisfies the condition. So the answer is 1, which is b.
All right, awesome. So for problem 19, you're given a systems of equations with ABC equals 100, A plus B plus C is equal to 10, and A plus 1 times B plus 1 times C plus 1 is equal to 20. When I saw this, and you're asked to find what is AB plus BC plus CA is equal to. When I saw this, the first thought I had was, if you multiply this out, what do you get? Because it looks like you're supposed to replace these values with these numbers. What you end up getting is ABC plus AB plus BC plus CA plus A plus B plus C plus 1, when you multiply this out, is equal to 20. Now, we can look at this and we say, oh, okay, we can replace this with 10 since we're given that value. Similarly, we can place this with 100, and we can say that this is our answer. So answer plus 111, which is 100 plus 10 plus 1, is equal to 20, which means your answer is equal to negative 91, which is your answer. I believe it's number D. All right, awesome. And now we're going to have Min on to do problem 20.
So, for number 20, we were given a figure, and there was midpoint right there, and it was a perpendicular bisector where these two are equal length, and the problem said when we connected these two angles were the same, so it's an angle it was an angle bisector also. And since I'll just label the figures A, B, C, D, and E. And then, well, we know that since this triangle ADE and triangle CDE is congruent. So because it's by HL or H. So because it's right triangle and an angle and a side length is equal, so this should be also A. And since in every triangle, if there's A, alpha, and this angle here is alpha plus beta, so this angle right here should be 2 alpha. And when you look, there's a similar triangle ADB is similar to triangle CBA because two angles, this angle and this angle is the same.
D should match up with A. D should match up with A.
D should C A B A D B C A B, yeah. And since they are similar, oh, and we're also given that DC is 16 over 3 and BD is 3. And also, by the definition of angle bisector, we know that AB to BD is equal to AC to DC. And since BD is 3, AB over 3 is equal to AC. So, and if we multiply, if we just simplify, yeah, 3 AB over 3 is 3AC, and cross multiplying gives 16ab is 9ac. In other words, the ratio is from this to this is 9 to 16. So this should also be 9 to 16. But since these two side lengths are equal, we can say this is 8k and this is 8k. And back to the similar triangle. Since this is similar, BD over AB is equal to AB over BC. And if we just substitute the value we found, BD is 3, AB is 9k, so it's 9k equals to AB is also again 9k, and BC is 3 plus 16 over 3, which is 25 over 3. Now we can cross multiply, and we get 81k squared equals 25, and solving for k gives k is 5 over 9. And since we know that k is 5 over 9, we can look at this triangle. So when we just draw that triangle, it's a right triangle, so it has a right angle, and the hypotenuse is 16 over 3. And since the longer leg is 8k and k is 5 over 9, is 9 over 40. And by using Pythagorean theorem, it's not a Pythagorean triple, so you need to find it manually. So what I'm gonna do, these two have a common. It's 8 over 9 times 5, and this is 8 over 9 times 6. So this is gonna be 8 over 9 times k, like y, and y, 5, and 6 is gonna be a Pythagorean. We're gonna use the Pythagorean theorem. So y squared plus 5 squared is 6 squared. Y squared is 36 minus 25, which is 11. So y is right 11. So if you put right 11 here, so this length becomes 9 over 8 over 8, right 11 over 9. And the area, you can find it by multiplying 8 right 11 over 9 times 40 over 9 divided by 2. And we get 160 right 11 over 81, which is answer choice B. Okay, and Sushan will do number 21.
So if you have any questions, now's the time to ask. I'll erase this in 10 seconds. Okay, I'll erase it. Okay. So Kevin randomly picks two distinct numbers from the set 1, 2, 3, 4 and forms a two-digit number with the maximum possible value. Okay, so since you're not given like a lot of numbers to work with, this is a problem ripe for bashing. So let's just list the number of possible numbers Kevin could have written down. So Kevin could have written down 21, 31, 41, 32, 42, and 43. These are the numbers Kevin could have written down. And similarly, you can find the numbers Matt could have written down. And the numbers he could have written down are 21, 31, 51, 32, 52, and 53. And so we want the probability that Kevin's number is smaller than Matt's. Okay, so let's say Kevin picked 21. What numbers here are going to be greater than 21? Well, there are going to be 5 total numbers that are greater than 21. And for 31, there are going to be 1, 2, 3, 4 numbers greater than that. For 41, there are going to be 3 numbers greater than that. For 42, it'll be another 3. For 32, it's going to be 3. And for 43, it'll be another 3. And so the answer is 3 plus 3 plus 3 plus 3 plus 4 plus 5, all over the product of the total number of numbers these two could have picked, which is 6 times 6. And this comes out to be 21 over 36, which is 7 over 12, which I believe is answer choice.
Wait, but what about the number? What about the cases where they're equal? Wait, no, you're right.
Yeah. So I believe this is letter D. Yeah.
Awesome. So, so I'm going to erase this, and we'll move on to question number 22. All right. So 22 is saying that Andy has a set of numbers from 0 to 728. 728 can be rewritten as 3 to the 6 minus 1. So, so he has a set of numbers from 0 to 3 to the 6 minus 1. And he writes them in base 9 and in base 3. So because this number is 3 to the 6, we can say that there will be 6 digits in the base 3 number and 3 digits in the base 9 number. And now what Andy does is he adds up the digits of each number together, and he tries to find the number of cases where the sum of the digits in base 9 is greater than the sum of the digits in base 3. And the way you solve for this is so you can say that these two digits, the true value of this in base 3 is equivalent to the value of this digit in base 9. And you can say the same for these as well, where these digits directly affect what's here because it's the same number. Now, if we just plug in some test numbers, say we put in a 1 here, that corresponds to an increase of 3 here in this base 9 number, which means the base 9 number is greater. But we want, so this actually can't work, because we need to find the number of cases where the base 9 number is not greater than the 3. Or because the bit, so, but if you plug in numbers here, like say there's a 2, this will also have to be a 2. And what this lets us know is that the base 3 number is never going to be larger than the base 9 number, but it can be equal to the base 9 number. So you have a couple distinct possibilities for each option. You can put in this has to be 0 because remember the 1 to the 3 ratio, which doesn't work, and it won't make it equal. Similarly for this and this, but you can put in a 0, a 1, or a 2 into this value, and have it output a 0, a 1, or a 2, which keeps these numbers equal. You can do the same thing for each of these. So we have 3 different options here. We have 3 different options here because you have 0, 1, and 2. And you have 3 different options here because you have 0, 1, and 2. We multiply these together, and we have 27 total cases where the digits in base 3 are not less than the digits in base 9. If we figure out the total number of cases, that's equal to 729 or 27 squared. We divide 27 by 27 squared and get 1 over 27 for the cases that don't satisfy our condition, which is that base 9 is greater than the sum of the digits in base 3. So for our value, we do 1 minus 1 over 27 is equal to 26 over 27, which is answer choice D. All right, I'm going to leave this up for a couple more seconds, and then I'm going to do problem 23. All right, awesome. So problem 23, in problem 23, Bob is playing a strange card game where he shuffles his 10-card deck, draws 3 cards from it, and then discards the lowest valued card, doing this until he has only 3 cards left that he hasn't discarded. And you're tasked with finding the probability that Bob's final hand of 3 cards adds up to 27. So Bob has cards 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we need to find the hand that sums to 27. The only hand that does that is a hand of 8, 9, and 10. So we know that his final hand has to be 8, 9, and 10. But he can't have this hand any time before his final hand, because if he drew this hand before that, he'd discard one of these cards and it wouldn't work. So the way we say that this has to be his final hand is we say that the last card he draws has to be an 8, a 9, or a 10. The probability of a single card being on the bottom is 1 out of 10 because there's a 1/10 chance that card will be on the bottom. So you have a 1/10 possibility for 8 being on the bottom, a 1/10 possibility for 9 being on the bottom, and a 1/10 possibility of 10 being on the bottom, which gives us our final probability of 3 over 10 for having his final hand sum to 27. Your answer choice is A. All right, now I'm going to pass it on to Min for problem 24.
So for problem number 24, we are given a polynomial p of x is x cubed, and this is satisfied by the values 1 through 2018. And now what we're gonna do, we're gonna make another polynomial which equals to px minus x cubed. Well, this, when you think about it, if you plug 1 in, it's gonna produce 0. Same thing for 2, 3, all the way to 2018. So, in other words, 1 through 2018 is a solution to this new polynomial. So we can write this as a times x minus 1, x minus 2, x minus 3, all the way to x minus 2018. And we're trying to find p of 2019 minus p of 0. And what we can do, we can try to find, if you do q of 2019, we know that this is p of 2019 minus 2019 cubed, and we can, when we plug 2019 as x, we can put it into this equation and also this equation. If we plug it into this equation, we get this, and if we plug it into second equation, we get a times 2019 minus 1 is 2018, 2017, 2016, all the way to 1. So it's 2018 factorial. And this means P 2019 is a times 2018 factorial plus 2019 cubed. And if you do the same thing for Q of 0, that's P of 0 plus minus 0 cubed, but 0 cubed is 0, so it's just P of 0, which is also 8 times, this is minus 1, minus 2, minus 3 until minus 2018, but since this is even number, the minus is going to cancel out, so it's going to be 2018 factorial. So we know that P 2019 is that, and P of 0 is this, and 8 times 2018 factorial is in common. So if we subtract this and this, these are going to cancel out, and only thing that's going to left is 2019 cubed. And we're only trying to find a remainder when this is divided by 1,000, so these two digits doesn't really count, so we can just do 19 cubed, which is 361 times 19, 6, 8, 5, 9. So when this, divided by 1,000, the remainder is going to be 800,559, which is letter D.
Okay, so now we're gonna move on to number 25. I'll keep this up here for a few seconds, and then yeah. Okay, number 25. In triangle ABC, the centroid is G and the incenter is I. If GI is parallel to BC and AB equals 10, how many possible values are there for AC such that the perimeter is an integer and the area is rational? Okay, so I'm going to start off just by hopefully I have enough space. So I think hopefully it'll be fine. Okay, I'm not gonna draw, or actually, I'll just try it actually. Okay, so this point is the incenter, and this point is the centroid. So it says this is parallel to BC. It also says AB equals 10, I believe. Yeah. So I'll just write 10 over here. So just a property of medians that we should all know, or you should know before the test, is that this ratio of, let me label this, I'll label this D, I'll label this H. So AG over GD equals 2 over 1. So just the medians are cut into 2-to-1 ratios by themselves. Also, pretty much the main thing that you have to notice for this problem is that GI is parallel to BC. So for any problem, always make sure to use every single condition because the conditions are given for a reason. So from this problem, since these GI and BC are parallel, we also know that AI over IH is equal to 2 over 1. Okay. So it said that, okay, so I is the intersection of the angle bisectors and G is the intersection of the medians. So okay, so that means those angles are equal. And now we know that by the angle bisector theorem that AB over BH equals AC over CH. And this also equals AI over IH. So this is so that was by the angle bisector theorem, and given that we already know that AI over IH is 2, that means AB over BH also equals 2. So that means BH equals 5, since we're given that AB equals 10. So now that we know that BH is 5, we can just label AC and CH as 2x and x. So just call that 2x and call that x. Okay, so now it says that how many possible values are there for AC such that the perimeter is an integer and the area is rational? So we labeled AC as 2x. So we want the perimeter to be an integer, and the perimeter of this triangle is going to be 15 plus 3x. And then given that the perimeter is an integer, this also means that x must be an integer. So now we have that x must be an integer. So, okay. Now we want to find the area of this as well. And now we're going to do this by Heron's formula. So the Heron's formula states that the area equals square root of s times s minus a times s minus b times s minus c, where s is a semi-perimeter. Okay, so for this, we're gonna have, yeah, okay. So the semi-perimeter is going to be 15 plus 3x over 2 times, I guess I'll just 3x minus 5 over 2. So I'm going to label this side, or actually I'll label this as A, this is B equals AC, A equals BC, and C equals AB. Okay, So that means s minus a should be 15 plus 3x over 2 minus 10 minus x, or minus 2x. Okay. So I'll write this down too. Equals 5 plus x equals 10, and this equals 2x. So now we're gonna subtract, so it should be 5 plus x over 2. And then s minus b, where b is 2x, it should be 15 minus x over 2. And then s minus c is 10, so it should be 3x minus 5 over 2. And then square root of all that. Okay, so that should be the area. And we also, so the area must be rational. And since we know that all of the x's are integers, that means the area must be rational. So now, okay, we're gonna want to simplify this. So, Jason, is this on the board? Okay. So I'll write it up here then. So we have our area is equal to square root of 15 plus 3x over 2 times 5 plus x over 2 times 15 minus x over 2 times 3x minus 5 over 2. Okay. So this is equal to 1/4 of, okay, I'll start factoring now. So this is a minus, okay. So you can take a 3 out of this. So then we'll get 3 times 5 plus x times 5 plus x times 15 minus x times 3x minus 5, which gives us 15 plus 3x over 4 times square root of 15 minus x times 3x minus 5. Okay. So, or actually, wait.
Yeah, how did 3 go out?
Huh?
How did 3 go out of that?
Oh, okay, okay. Yeah, you're right.
Only 5 plus x.
Okay. Yeah, yeah. Okay. Let me see. So this should just stay at x plus 5. And times 3x minus 5 times 45 minus 3x. Okay, yeah. So 45. Okay. So I just multiplied the 3 into 15 minus x to get 45 minus 3x. So this is what the area is going to be equal to. And now, okay. So we're trying to find the number of values for 2x, which is AC. So that means, I'm going to write this, let's move this over. If I said this is A and this is B, we know that A plus B is going to be equal to 40, and AB is square. So, okay. So let's say A is equal to TR squared and B is equal to TS squared. So, so that means A and B, wait, yeah. Okay. Yeah. So that means A plus B is equal to T times R squared plus S squared, which equals 40. So that means now we have T and R squared plus S squared are factors of 40. So that means, let's just say r squared plus s squared can equal all the factors of 40, which are 1, 2, 4, 5, 8, 10, and 20, and 40. Okay. So, yeah. Oh yeah, I put that. So, I'm just gonna check if this is right. So, 40 equals 2 cubed times 5, so we should have 8 factors. So, yeah, we have 8 factors. So that means r squared plus s squared equals this. So now we're gonna have to do checks for what r and s can be, and then given r and s, we'll know t, and then we can find a and b. So so for 1, nothing will work. For 2, okay. So I'll just try it. R squared plus s squared equals 1 doesn't give anything. R squared plus s squared equals 2. R equals 1. S equals 1. R squared plus s squared equals 4. Shouldn't give anything. R squared plus s squared equals 5. R equals 2. S equals 1. R squared plus s squared equals 8. R equals 2. S equals 2. R squared plus s squared equals 10. R equals 3. S equals 1. R squared plus s squared equals 20. R equals 4. S equals 2. And then r squared plus s squared equals 40. Gives r equals 6 and s equals 2. Okay. So for all of these, we have t equals 40, t equals 20, t equals 10, t equals 8, t equals 5, t equals 4, t equals 2, and t equals 1. Okay, so now we have to check the values of A and B. Yeah. So once we check the values of A and B, we can check the number of values of B, which is AC. So for a problem this difficult, you want to always keep track of what you're solving for. Yeah. So let's go through it. Hopefully I haven't made a mistake so far, but this should be a very good direction towards what you're supposed to do. If I did make an arithmetic mistake, it'll just be a exercise for you guys to go home and try to solve it. Yeah. Okay, so we have A equals TR squared and B equals TS squared. So from here, okay. From the r squared plus s squared equals 2 case, we get A equals 20 and B equals 20. From the r squared plus s squared equals 5 case, we get 32 and B equals 8. From the r squared plus s squared equals 10 case. What is it?
20.
Okay, so A equals 20, B equals 20. From the r squared plus s squared equals 10 case,
36.4.
we get A equals 36, B equals 4. And from the r squared plus s squared equals 20 case,
32.
we get A equals 32, B equals 8. And from the r squared plus s squared equals 40 case, we get A equals 36 and B equals 4. Okay.
Only 3 cases left.
So now we also have to try. Okay, so now just the number of different numbers we get is 20, 32, 8, 36, and 4. So I didn't write out that if r equals 2 and s equals 1, we can also have r equals 1 and s equals 2. So for each of those cases, there's going to be a flip. So these will all of these will be flipped as well. So that means we can just count the number of numbers that we have for b. So that means, or the number of different numbers that we have between a and b. So that means we have 5 numbers for, and b is ac, and that's equal to 2x. So okay, I forgot what we're finding. Okay, so how many possible values are there for ac? That means, yeah, for 2x, which is b, we have 5 possible values. Yeah, this is D, which is the correct answer, I'm hoping.
Actually, you can
Yeah, it's D.
eliminate 2 cases because
It's okay. This is just a number.
this is impossible because this is b and we know x is an integer. So this plus 5 should be a multiple of 3. So only case it works is this case. So a is 36 and b is 4.
The answer's 5.
Yeah, so x should be 3.
We're not solving for x, we're solving for number of b's, or number of cases for b. Just number of different numbers for b. Everything should work. I checked it.
Okay.
Yeah.
It's not hard.
Yeah, so yeah, that should be the end of it. Yeah, thank you for watching. We'll have Hannah do our outro with
Okay.
the rest of the Pure Genius.
Yeah, so how about everybody come up here? Okay. Thank you, gurus. They all did a really, really awesome job today. We just wanted to thank you guys for joining us today on the live. Check your emails. We will be sending out a survey shortly, which is like feedback on like what we can do better for next time. Yeah, and that's all I really have to say. Again, we all are so grateful that you guys joined us today. And if you guys have any questions, email puregenius@ochacker.org and we can answer any questions that you might have. Thank you.